Hello, everyone. Welcome to Ops 210. We're going to be talking about infrastructure as code and how you can do it at scale as an enterprise. I'm Morgante Pell. I'm one of our strategic cloud engineers working with our largest enterprise customers on all of our DevOps best practices and how you can really effectively use infrastructure as code. I'm with Andrew here.
Oh, there's actually two clickers here, which is nice. Thanks, Morgante. I'm Andrew Phillips. I'm a product manager in GCP working on continuous delivery. Long story short, I've suffered on all sides of the software delivery space. I've also been a head of duct tape, so hopefully head of infrastructure officially. So hopefully have some good familiarity with what the challenge is here. Just a quick reminder, there's mics here, so we will obviously be taking questions live as well. But if you do have a question at any point during the presentation, you can put it in the dory using your app, and then we will try to answer them from the floor and also from the Q&A, and we'll obviously get round to any that we aren't able to answer here. OK, so let's set the stage here. What's the actual problem that we're trying to address? Well, typically, what we see quite frequently is when users or companies or teams get started with the cloud, oh, yes, I have access to a cloud project. That's great. And let's follow a couple of tutorials, or let's try a bunch of things out. And then I copy-paste some commands, and then I click around a little bit to set up some configuration. And eventually, I have my POC environment running, or I've tried a few things out. And I got a bunch of things that I've created, maybe some networking config, maybe a couple of clusters here and there, maybe some VPC stuff, and a couple of buckets, and so on and so forth. And I mean, there's a whole bunch here, some IAM permissions. But it's kind of manageable, and maybe some of it's not necessary. But if I have a few things lying around, that's not terrible. And actually, GCP does a nice job of warning you about things that haven't been used, and so on and so forth. But let's imagine you decide that you really like this. This cloud stuff is great, and you feel it's going to help your company a lot. And then you get all your development teams or your friends to work on it. And then you add more resources. Suddenly, you've got a whole bunch of projects. So maybe you want to start doing some stuff at a more org level. I mean, org as in the GCP construct. So you don't have to set up the same permissions or the same policies, these kind of things all over the place. So you've now got two places where your config is already living. And then I think you kind of know where this is going, ... Suddenly, you're all in on the cloud. You've got tons and tons of projects. You've got org-level config that's quite complicated. And you have all these 500 projects, each one of which is set up, well, similarly, but then slightly differently. And some of them are maybe in compliance, and some of them are out of compliance. And really, config sprawl, I think most of us have heard this term. We don't want to go there. If we have been there already, we want to get out of it. And if we haven't been there yet, good for you. But we're going to talk about how we can try to prevent this. What's the answer? At least what we're going to be talking about today is how we can manage this complexity with relatively well-known patterns, thankfully. So there's nothing too crazy here. Using infrastructure as code and automation to handle both the definition and the safe rollout of configuration to all the various places that we need to have in GCP. And we're going to look at a couple of tools to do this, a code repo. We're going to look at Cloud Build. And we're going to look at deployment templates here to reflect the configuration that we want to have. So what are some of the benefits of using infrastructure as code? Well, similar benefits to using any type of config as code. You've got all the nice bits about using code management. Things are versioned. You have things like stable IDs through commits, so you can always point back at a previous version. You can have multiple people working on the same things, et cetera, et cetera. You have this idea that rather than infrastructure being in whatever state it happens to be in, you actually have a place that specifies what you want the infrastructure to look like. And that's useful for things like drift detection or just as an audit trail, but of course is relevant also for things like disaster recovery scenarios if you want to bring back something to the state that it was, and so on. It's nice and declarative, so rather than hiding the intended state in a bunch of gcloud commands or in a bunch of imperative commands, you can actually look at it, and it's hopefully human readable, and it gives you a sense of what it is that you were going to set up. I talked about auditable a little bit, and then of course it's modular if you have the right type of config as code or infrastructure as code tooling or language that you're using. You don't just have to have one enormous flat file that is copied or duplicated all over the place, some parts of it. You have the ability to do things like inherit sections so that you can have a shared definition for maybe some networking config that you use in a whole bunch of different places. So we talked about code. We talked about some of the benefits of managing this configuration as code. And what we've learned when we talk about source code over the years is that there are certain practices that are really useful in order to make sure that we don't break stuff when we build applications. And if we're going to think through what CI/CD or what deployment might look like for infrastructure as code, we can use exactly the same processes by analogy to think through what that might mean. So most of us have probably heard of continuous integration for application code. The idea that whenever I submit or propose a change to my source code, I should run a whole bunch of tests and verifications to make sure that this change actually is going to be good and not just eyeball it and think like, oh, it looks fine, let's try it out. And of course, we can do something similar for infrastructure as code. I'm proposing a change to my infrastructure definitions, maybe a change to a firewall config or something like that. And automation can give me a lot of information about whether that change is safe, whether that change is good. At the very simplest level, automation can tell me whether I actually have made a syntax error and the new config as code is broken or is not broken. And so we'll talk a little bit about how we can, what kinds of information we can feed back to whoever is working with the infrastructure as code in order to make sure that we have good confidence that the code change we're proposing actually works. And then if we follow that analogy a step further, yes, we've assured ourselves that a code change or a config change that we're going to make is safe. But now, instead of just saying, great, let's just apply it everywhere and see what happens, what we've learned with application releases is that it makes sense to have a gradual progression, some process where we maybe run some integration tests, or we have a staging environment, or we maybe even do advanced things like a blue-green deployment. There's lots of practices that we've discovered that make the rollout of a new config or a new application change safer. And of course, we can do the same thing for infrastructure as code as well. We can think through how we can safely roll out these config changes progressively to the places where they need to go, as opposed to saying, oh, I've approved the change. Now somebody gets their laptop, clones the repo, and goes apply, or does that in Cloud Shell or somewhere else. And as I hinted at when I talked about the progressive rollout, one of the dimensions that come into this is that, of course, we have multiple environments in most cases. You don't just have one set of config for one GCP project or one environment. It's very common that as we think about our infrastructure landscape, we have this notion of logical differences. We have the dev environment or the test environment or the staging environment for our teams or our applications. And we also have inevitably differences across those environments. And so what we want to do is, we want to be able to reflect that difference in our infrastructure as code, so we can easily see what the state of our dev and test and staging environments should be. And we also want to have a rollout process that takes these changes through the various environments so that we don't, we can if we want to, but it's often safer rather than applying the changes to everything at once. Let's take an example case. If you're going to change a firewall rule, it's kind of useful to change it in the staging environment first to see if your application still works before you decide to apply that same kind of change to your production environment, where if you get it wrong, you might be breaking your users who suddenly can't access the application anymore. So there's a longer, let me just pause at this. There's a longer discussion about how environments map to different GCP projects. And I think the short answer is that there is no right answer, but we are very happy to talk about different patterns there. Suffice it to say that from the perspective of what we're going to talk about today, it doesn't really matter. Your dev and test and staging environments could all be resources in the same project, or they could be spread across multiple projects. So having taken these principles about CI and CD, let's now look at how we can actually technically use tools that are available to implement this kind of flow. So what we're going to have a code repo that has infrastructure as code definitions for multiple environments. We're going to submit or propose a change to this definition, or rather, Morgante will, because I just do the hand-wavy slide bit. We're going to have CI, an automation process, providing feedback on that pull request. to tell us about whether it's a good pull request or not. And we'll talk about some tooling we can use as part of that process to give us more useful information. Then we're going to have a review process. The nice thing about using a code repo is that we kind of get that for free through the pull request model. And there's actually some nice, if you, depending on which repository service you're using, whether it's GitHub or GitLab or Bitbucket or whatever, did you say GitHub? GitHub. You have nice options about adding access control, and you can require that certain people are the only people who can do reviews and so on. Somebody's going to review this code change after we've got the feedback for things like policy compliance. Then we're going to decide maybe or maybe not it's good to go. And then, of course, once it's done, we are going to take this config change, and we're actually going to apply it progressively to the various environments that it has to go to. So what are some of the design principles, if you like, in terms of the automation that we're going to be looking at here? We're going to be using some release pipelines to do the automation. So that's going to be not going to be somebody following a wiki page. That's actually going to be fully automated. And again, we're going to see that we can store this automation in a repo as well as Config-As-Code. We're going to have a sort of equivalent to integration testing or to testing. Obviously, for application code, we understand what integration testing means. But there are analogies for infrastructure as code as well. The pull requests give us some manual judgment. And of course, given that we have the last version of the config in our repository, because we're just changing it in a version store, we also have a nice vector to do things like rollbacks. So basically, I guess the long story short is that all the good design principles about CI and CD that we apply for applications, we are also able to apply for infrastructure as code here. So to get a little bit more detailed, this all sounds, I think, hopefully very nice and compelling. But now you actually have to make some concrete decisions about, OK, I've got this batch of infrastructure as code. I've got multiple environments. I'm going to roll them out. How do I reflect that in my repository? And again, while caveating it by saying that there's no perfect answer for all situations, what we're going to present here is a templated pattern, or one particular suggestion that you can use and you can think about using in your setup. And again, this is not the only way to do things, and I'm very happy to discuss variations depending on your use cases afterwards. But we think this is a really good place to start. So what we start with is we have a master branch that will include in different folders. We start with a master branch that will include in different folders the configuration that we want to have in each of the different environments that we're rolling out to. Now, this means that this is what we want to have. This doesn't necessarily reflect what is actually running in each of those environments, but it tells us what the kind of, this is what we want to move towards. And especially as we make changes to it, so we might open a pull request against this branch, for instance, to change the information in the prod folder. That means that we are thinking about making a change to the prod config. It doesn't mean that the prod config has changed yet. One of the things that we've learned around Kubernetes, this is very popular, but in fact, this can be done with any kind of system, is the idea that with GitOps, or with environments as code, as I like to call it, it's very useful not just to have what we're talking about here, which is that you have folders that represent the desired state, but that you actually reflect also in version control what the actual state of your environment is. So as we start doing the deployment, as we start applying this config across our various resources in GCP, we want to have that actual state reflected in our repo as well, because that gives us a history not just of what we wanted to happen, but of what actually happened. So what you will see is that the state of master is intended to reflect the state of the dev environment. Right? So what is in master? When something is in master, we think that that is what the dev environment should look like. And so the automation is set up. You'll see that in the demo, that as we merge changes into master, the job is, or the intent is, that that should mean make the dev environment look like this. The next stage in the progression is, once we're happy with the dev environment and we want to move forward, we will take the staging environment, the information that's in the staging branch, and we will apply that to the staging environment when it's merged to a particular branch called staging. And then when we are happy with the outcome of that, we think everything is OK, staging actually looks OK, the apps are still running, we want to go forward and affect our production environment, we will take the changes and we will apply them also to the prod branch. And that will show us what is actually in prod. So if you look at the prod branch in your repo, that will tell you what actually happened or what the state of the production environment really is right now. It's somewhat abstract, and it will become, I think, much more real when you see the demo in a second. And so for that, let me hand over to the magic that Morgante is about to show us.
Thanks, Andrew. So, sorry, skipped ahead there. So for my first demo, what I want to focus on is actually the shared foundations. That's the stuff that we were talking about that's not necessarily project specific. This is things like networking, billing, IAM, security controls, all the stuff that is shared across the organization. Often you have a central team that's running this sort of thing. And it really is very important because it affects so many different parts of the organization, and so many different applications can depend on a shared VPC, for example. So we're going to show how you can actually do that through Infra-As Code and have the same pattern of rolling it out across multiple environments, specifically using Terraform, which is a open source tool developed by our partner HashiCorp. It has support for multiple clouds, but great support for Google. And in fact, we actually have a full-time team of Google engineers who work to make sure that there's good support for Terraform on GCP. All the same patterns that we're talking about here can be used with more or less any Infra-As Code tool. You can use them with Google Cloud Deployment Manager. You can use it with Terraform. You can use it with Ansible. You can use it with whatever tool you're using to. But today, we're going to be looking at Terraform. And one of the big things it actually has is different plugins and different providers. So the Google provider is maintained primarily by Google engineers. So just to go ahead to the demo. There we go. Cool. So here I have my deployment repo. So this is just a simple repo. It's for my little sample organization that I have. And one of the big things that we have as a principle is that you actually want to separate it out so that you don't have all of your code in a single folder for all of your environments, or even for a single environment, all of the different purposes. You want to separate that out by different purposes, and particularly by different teams that might be maintaining it. So often a pattern we'll see is that there's a networking team, for example, that's maintaining networking config, comprised of both automation engineers as well as any traditional network engineers that might be involved in looking at that as well. So within this networking folder, I have, like Andrew was talking about, I have my different environments. In this demo, I'm just doing a very simple dev and prod, so we can have simplicity there, where we have each of the Terraform files. One of the things you notice here is that we actually also have some files in the root. This is for files that are shared across multiple environments. So I don't have to copy and paste the exact same file into each environment. I can actually have a shared file and just symlink it into each directory where it needs to be used. And Terraform automatically can pick those up. Deployment Manager can as well. So you can very easily share code across these environments if you need to, if you want to have the same file without copy and pasting. So let's jump into the dev environment here. So here are a couple things that matter in this file, in this folder. Each of my environments, I want to make sure that I have a backend config. This is used for storing the Terraform state, so that I'm making sure that every change I made is actually still stored on Google Cloud Storage, so I can roll back if I need to. I have version history there. If I want to collaborate across multiple different CI runs, it actually has locking in place, so it's going to make sure that 2 different CI runs aren't attempting to manipulate state at the same time, as well as the ability to revert back if necessary. And then I've got the provider config. I've got a couple of variables for things like what my org ID is, if I want to be able to have that be easily substitutable. And then in my main.tf is where I start actually configuring what my dev networking environment looks like. As you notice, most of the actual code that goes into these individual environment folders can actually module or template references. Because in many cases, you want to share code across different environments. So you don't want to actually have all of the config and all of the complexity be in the individual environment-specific folders. You just want to have the configuration that's specific to that environment. So I'm using this VPC module, which is one of our open source modules that we have for working with Terraform on Google Cloud, which is used for setting up a shared VPC network. So I specify what my project ID is. I specify which subnets I want. So I want 2 subnets in here. I specify any secondary ranges I want for those subnets as well. And then this is all, of course, very specific to the dev environment, because I'm not going to use the same IP space, for example, between both dev and prod in most cases. Right? So this is configuration that matters, just the dev environment, but I'm able to use the same module in both environments. Other parts of the configuration might be even more shared, where it's the case where you have the exact same firewall rules in both environments. So this is where this shared firewall rules module comes in. I'm able to reference this module and just pass in the dev-specific information, like the network name and the host project that applies to my dev environment, into the shared module, so I'm not having to write the same firewall config for each environment that I'm doing. So that's just a relative reference to the same repo. So it goes up to this other modules directory, where I actually can have shared bits of code that I want to share across different environments. It's very easy to build a module or template in both Terraform and Deployment Manager. You just create a file, create a folder, you have a module instantly. There's no registration process. There's nothing special you have to do. Any folder with a Terraform file in it automatically becomes a module. So this is my module just for shared firewall rules here. Very simple. Just has a couple inputs of which project I'm hosting my network in, and the network that's on the name for that network, which I also use in the firewall name. And of course, I have my rules. Right now, I only have a single firewall rule, which allows HTTPS. But let's go ahead and modify that and add an additional rule. Let's say we realize we actually have to at least serve a redirect on HTTP because people are going to our website and realizing and getting frustrated they couldn't access it. So we're going to just add an allow HTTP rule. Let's put it there. And let's just use the same. We can use the same target tag. So this config looks good, and I'm going to be really dangerous here and actually just commit it directly into the master branch. Obviously not what you'd want to do in the real environment, but we can start to see, and we'll talk more about how you can actually build an overall pipeline for that. But we'll just say add new firewall rule. All right. And as soon as this is pushed into the master branch, Cloud Build picks it up and is going to start to build that. Right? So here you see push to the master branch, deploy networking to the dev environment. So we have a Cloud Build pipeline that automatically captures that, runs Terraform init in there to make sure that all the modules are downloaded, make sure everything's in place to be able to run everything. You can see it pulling all the Docker containers here to run everything there, and then actually goes and applies it to my environment. So here we see we download the Google provider, the latest version because I didn't have it pinned, and then the null provider. And then we can actually see what's being created. So we can see the allow HTTP firewall rule is being created in my dev environment on that project as I expected. And we notice we actually have some of the variables get interpreted. So dev VPC allow HTTP. So we had that as expected. And everything's complete, all set. So if I go over here, go to my firewall rules, I can see I now have the dev VPC allow HTTPS and allow HTTP. But this isn't on prod yet, right? Because we only did it on dev, and we want to make sure everything's working great. We want to make sure we get a chance to test that. Maybe we do some security testing, make sure that we're not somehow exposing our application vulnerabilities that way. But it's only on dev. Now let's say everything looks good. The firewall rule is great. We want to promote the same change to production. That's just a process of doing a pull request from the master branch to the production branch. So I'm going to go ahead and go into my root and create a new pull request. So the base, I'm still going to do on my repo. And I want it to be actually my production branch. Right? Only change here was that new firewall rule. Otherwise, they're up to date. So we can say, yeah, I'm going to do this as a release candidate, basically. Right? So I'm going to say, this is what I want to move from the dev branch into production. There's a pull request here, so there's a chance for anyone who wants to give feedback on it. They can come in and provide any details they want. Everything there. Maybe you have to have a certain number of reviewers happen on any production push. You could say that they have to come into the pull request and put the looks good to me for them, but you can actually have all your reviews and all of your processes in place just through the pull request as that sort of your ability to have manual judgments in place as well as any CI you want to run. It says there's no conflict, so I can go ahead and merge. So I'm just going to merge it. And that'll kick off an additional cloud build. So we push the production branch. So now we can deploy networking to production. It's going to run along, do the same changes there. And in a minute, it'll show up here with my new firewall rule there. One of the other things you can do actually is also with the folder structure that I was talking about, you can actually have different owners for different folders. So you can do something with most Git systems support some form of ownership, but you can basically have an owner's file in each of these directories, and similar to what we do at Google, where you can say, the networking, we want a network team member to give a approval on any change that touches this part of the code. So you can put that in the owner's file in the networking folder. You could have a different part for, say, security changes that you want to have a team there. So you can have a lot of configurability over who has to approve different pull request types based on what infrastructure is being affected. Cool. All right, that's finished. And there we go. We had the same change applied to prod. We had confidence, then we had the exact same commit being pushed into both branches. So we have full confidence that we're having the same changes being promoted across the life cycle. Cool. Can go back to the slides. Cool. So I mentioned modules. They're a primary method of code reuse in Terraform. I should have showed a definition of this. One of the really nice things is you can load modules from many different sources. So you can do it from a local repository, like I showed there. You can pull from the Terraform module registry, which is lots of opinionated best practice modules out there, so you don't have to go out and write your own module every time you want to do a network or do a firewall rule, for example. And you can also pull modules straight from GitHub, too, or actually any Git instance. So if you have an internal GitLab repo, you can easily pull from there. But you can easily share modules, and they're the best way to actually do code reuse in Terraform. In fact, we've done something called the CloudFormation Toolkit, which is a set of example and sample modules for Terraform that represent our best practices and experience with enterprise customers. So these cover things like creating your core VPCs, creating projects in a repeatable way, managing IAM permissions, creating GKE clusters that are secure and deployable effectively. And we have these templates for both Terraform and Deployment Manager that you can download totally open source, all on GitHub. And we actually, for Next, made a nice website for it. So you can go there, and I'll have the links to everything and shows you how to use it and some tutorials there. The benefit of this is you actually, instead of you having to discover all the best practices yourself and every team that comes onto GCP having to figure out how to create a project, you can just take the modules that has all the best practices baked into them, and you can focus on the parts that are specific to your application use case and what's needed particularly for your, what's different about your environment instead of doing all the baseline stuff yourself. We also have some example cloud build pipelines. We'll integrate that into there as well. And the other thing we're trying to do is actually have secure defaults for all these modules. Because of the way that GCP is built, we actually want that really easy getting started experience that Andrew showed, that you can go on, start your free trial, start playing with some services, do a POC very easily. And that's really powerful because you can have that power of the cloud to experiment and play freely. But once you start going to the state where you're in an enterprise use case, you're doing hundreds of applications, you're moving entire workloads over, you want a little bit more consistency and repeatability, and you want more secure defaults. So that's what we baked into these modules. So these are things like making sure that you actually don't have internet egress by default on any project you create, making sure that you have GKE clusters by default have private IPs as opposed to public IPs. So it's a lot of enterprise defaults that we bake into these modules as well. So it's focused on sort of the enterprise use case versus the hobbyist or POC use case. Cool. So I said that I was doing something really dangerous earlier, and in fact I was, when I committed directly to production, right? I was able to push that change directly to development. There were still pull requests where I was going from development to production, but ideally no changes are made to infrastructure at all without some CI feedback. When we talked about the earlier pipeline, we talked about having some CI, some feedback that allows you to do some sort of testing and sanity testing on your code before it actually goes into production. So that's where having CI and cloud build comes in, and the ability to make sure that human error is accounted for. We found that the most common cases of insecurity in the cloud is usually because there's some human misconfiguration, some mistake, or some just simple misunderstanding of or even a typo of how the config is set up. It's often easy to have misconfigurations, especially when everything's in code. The machine is exactly translating what you have in the code, so you want to make sure that your code is right before you actually apply it. That's why it's easy, and then we also realized that actually can slow down cloud adoption, especially for enterprise customers, where if you're worried that developers could easily make a mistake and do what I did and just go commit directly into master and have that deploy into GCP environment, that can make security administrators a little bit worried. You want to make sure that you have the right guardrails in place. You want to make sure that you have everything you need, which is why we are introducing the idea of the Terraformed Balladur, which can actually look at your Terraform config, run policy checks against it, and determine whether that Terraform config violates any of these policies before any changes are made. So this allows you to have confidence in changes before they're deployed to production, before any of your GCP resources are updated. We can actually look at that config and give you full confidence that things like no external IPs are being exposed, that your firewall rules are not too broad, that whatever policies matter to your organization, you can have them embedded into your repo, embedded into your CI pipeline, and you can have the full flexibility there. We released this very recently, this v0.1, I would say alpha software at this point, but it's very early. But the idea is also we're trying to build a community. It's all open source, so everyone can collaborate on it. It's a CI binary you can download. You can work with it. And the actual policy library is also open source. So we've started with a handful of constraints that we think are best practices, things like not having external IPs, but we want to have more of them over time. And we encourage everyone to be able to contribute to that and actually have a full community-driven ecosystem of policies that everyone can contribute, share, and sort of have policy configuration as code, the same way that we're talking about Terraform modules for your actual code. You can have the same reusability there across the board with the Terraformed Balladur. How this actually works in practice is, as an administrator, you go to the Terraformed Balladur repo. You say, OK, here's the set of available policies, available constraints. I'm going to pick these 3 constraints that matter to me. No external IPs, no sharing IAM resources outside of my domain, and every project that gets created must have a label that's the cost center for it. These are totally flexible. Administrators can define which ones matter to them. But you can take it, put it into your own repo. So you take the public repo, fork it, pull it into your private repo, and enable the policies that matter to you. And then the administrator just says, here's our policy repo. Developers, anytime you're going to deploy into GCP, it has to pass this repo. If it doesn't, you're not getting into GCP. Then as a developer, I have the flexibility to actually start working on code locally and know if it's going to break policy before I actually even submit it to everyone. So I can have a very fast feedback cycle where I know I'm breaking policies before I even submit the code, right? So I, as a developer, locally write some Terraform code. I can run the Terraform Balladur locally, get immediate feedback there. And then once I submit it up into a Git repo as a pull request, I also get feedback there, so I can make sure it's enforced. Assuming the CI check looks good, then I can actually finally merge into production or merge into development branches and have the full visibility there. Cool. The other part of this is actually that you take those same checks, the checks that we were talking about where you have the pre-deployment checks as part of the Terraform, and those same policy library can be used for SETI, which is our open source security monitoring product, which allows you to do ongoing monitoring. So in case some developers somehow got console access, or there's some legacy infrastructure that wasn't in place before you had the Terraform Balladur in place, you have Forseti does ongoing monitoring against the same set of policies and just detection if there's any violations there. And we'll send you alerts, put them into the Cloud Security Command Center, or send you any email alerts that you need, any Slack notification. Make sure that if there's a violation, you know about it, and you can actually remediate it if necessary. I mean, you can go in and find out, so you have both sides, the same policy library used in both places. So you're both doing pre-deployment checks and ongoing monitoring to make sure policies are in place before infrastructure is created and as infrastructure matures and changes over time. Well, how the policies actually look like in practice, everything is very declarative in nature, very similar to Kubernetes-style APIs. So this is, if anyone who's worked with Kubernetes, this looks very similar to a Kubernetes manifest. So you have in here, this is for an IAM policy member. So you can say what constraint I'm using. So this is the IAM allowed policy member domain constraint. So just specifying where are members of my organization allowed to come from? So what domains are they allowed to use, right? You can specify which configs you want in there. You can also do targeting. So you can say that if there's a policy that you want that only applies to part of the organization, you can actually limit that down. So this policy, we have it targeting the entire organization, or actually, in fact, all organizations. But that could just as easily be targeting a specific folder or a specific project within the organization. So you have that flexibility to scope things down. If there's particular resources that are more secure, certain environments that have more sensitive data in them, you can have more restrictive policies on those versus a sandbox environment where you might have less restrictive policies. Similarly, you can have the exclusions. By default, there's nothing excluded. But you could, if you had, for example, a piece of legacy infrastructure that needs to run with an external IP for some reason, you could actually scope that down and put an exclusion in there for just that project where that infrastructure is running. So you could actually have whitelisting on those policies as well. So really flexible, all as code. So it's really nice. You can just check this into a repo. Your policies, you work on them the same way you're working on your config as well. You can also do custom logic. So this is an example of if you want to do, this is the Rego code. So Rego is an open source policy language that you can actually take that Rego language and you can write your own policies in it. So you can say, I want to have a custom constraint that's doing something like checking that my labels actually match the format for my naming convention, right? So you might have an internal naming convention that specifies that every project has to match a certain standard, has to have cost center embedded in it. You could just write some code that enforces that constraint, embed it into the policy library, and then all of your Terraform code that's getting submitted and all of your ongoing monitoring with Forseti would automatically pick up that constraint. So you have full flexibility to define your own policies. You're not constrained by what Google has available. So this is just an example of some of that logic. So now let's look at what that looks like in practice. Cool. So we showed this foundational infrastructure before. Now I'm going to put on my developer hat and start to deploy a VM. So this app that I'm working on is only in the dev environment so far. I haven't promoted it to production, but I just have an empty main.tf file for it. So I'm going to go in and edit this file. I've got my handy dandy VM here. So there's a couple things I'm here. I'm just going to create a simple compute instance for my backend service that I'm going to be deploying into GCP, specifying the region, the project that I'm on it. One of the really cool things I can do with having my Terraform state stored in Google Cloud Storage is I can do references across deployments, so that even though I'm not editing the networking state, I do actually have to reference it because I have to know what subnet to put my VM on. So I can actually very easily do that by referencing this Terraform remote state, which goes and pulls from the GCS bucket, gets the latest networking config that's been deployed into dev, and actually grabs what the app subnet ID is. So whatever export the networking team has identified as this is the subnet we want you to put your applications on there, all they have to do is export that, and I can just import that very easily in my Terraform config without ever having any manual configuration there. So this means the next time they, for some reason, have to change the subnet, they can easily update that, and my config automatically grabs the latest one. I don't have to worry about making any changes myself. So this looks cool. I'm going to do that. But this time, I'm not going to commit directly to master. I'm going to be a good, safe developer and start a feature branch. Cool. So we're going to create a feature branch. Let's put in a nice pull request name. Cool. And this immediately kicks off a cloud build. Now, unlike our previous cloud builds, this one is actually just doing testing. It's not deploying anything, right? So the first thing it does is just runs Terraform init as before, but actually does Terraform plan. So I can go in here and look at a plan of what's expected to be created. So I can see it's expecting that it's going to create a Google Compute instance. It's going to have these parameters, what IP forward. It's going to be on this this network. You can see which subnet. So the actual subnet gets filled in and completed there. So earlier in my code, I just have it as a variable, but here I can see, oh, this is the US one. It's subnet dev subnet 01. So I can make sure to do a sanity check there, make sure everything looks good to me. And then finally, it actually passes it into the Terraform validator, right? And found violations. Constraint forbid external IP on resource. Resource my front-end instance, no external IPs are allowed. So I accidentally put an external IP on my instance, even though my organization has a policy of no external IPs. Now, if this config had been merged earlier, I would have accidentally exposed my network to the internet, and we could have easily had a big issue where there's IPs, I might not have had the right firewall rules, I might not have the right security software on that VM, and I might be getting a call from security. Thankfully, this got caught before anything was actually deployed, and I had the full ability to know about that. In fact, the check failed. Right? So GitHub's not even going to allow me to merge that pull request, except if you're administrator, because the check failed because my policy was violated there. Right? And I can go back to the cloud build, look at me details on that, but I'm having this enforcement of the policy compliance at the build stage with the CI checks that we were talking about earlier. Now let's go ahead and update that again, because we want to make sure that we actually can deploy, because we want to have a little bit of, we want to make sure that we can take off that external IP. So if I go here, go to the main.tf that I have on my branch. And we're just going to take off this access config part, because the access config is actually what gives it an external IP. So I commit those changes. I go back to my pull request. It's going to rerun the CI on it, because I updated my main.tf again. It's going to do a new Terraform plan, so I can make sure that whatever change I merge is the latest Terraform plan, so I have full visibility into that. And yep, just have to pull these down. And you notice how the fact that access config by itself automatically creates an external IP isn't actually always entirely intuitive. So that's one of the benefits of this, is that even if somebody does something like just copy and paste an example from the internet that looks correct, looks intuitive, we'll make sure you can detect those violations and you can detect misconfigurations before they're applied. Cool. So cool, I see my Terraform plan and no violations found because I don't have an external IP now. If we go up here and look at it, we see, oh, cool, there's no external IP on this. There's no access config for this network interface, and there's no external IP associated with that. So I'm just going to go ahead and merge that, because I can merge now because there's nothing blocking it. All my policies passed. And that itself will also kick off another CI run to deploy my app to dev. So I can actually automatically have my instance deployed, doing everything just through GitHub and through the CI workflows. And in a minute, it'll actually deploy the instance up to here. Yep, there we go. My front-end instance is being created. Cool. Can go back to the slides. Cool. So that's the demos we have today. The key takeaways: check out the CloudFormation Toolkit to get the templates for Deployment Manager in Terraform, so you can get started really easily. Check out the Terraformed Balladur to make sure that you have more reliability in your infrastructure as code pipeline, so that you can detect policy violations before they actually happen. And make sure that you can have security by actually doing cloud build pipelines, so you don't have to do any management yourself. Nobody's logging into any consoles. I never actually touched it. I never touched a shell in this entire demo. I was just working entirely on GitHub. So you can collaborate on your infrastructure entirely through code, never touching a shell, and use the cloud build pipelines that we have example. Grab these links. And I think we have a dory open for questions if you have any, as well as we have mics around here if you want to walk up and ask questions too.
Let's give Morgante a round of applause.